Hi grade 8s, how are you today? This is the first lecture of term 2, our first video lecture. We're also going to be doing Skype sessions once a week, so those we're going to do face to face, and we're going to go over these video lectures and the exercises that I've given in the Skype sessions. So I'm not going to teach you in the Skype sessions, I'm going to ask, that will be more questions and answers, and during these video lectures throughout the week, I'm going to give you some material, some lectures or lessons from the textbook, and then exercises that follow. All right, cool. So let's begin with term 2's work. We're going to start on page 74, and that is topic 8, which is algebraic expressions over here. Okay. So last term we've started on this, and I'm sure you'll remember from grade 7 that we get algebraic expressions and algebraic equations. The difference between the two is one has an equal sign and the other one is just a bunch of terms written together. So if I say 2x plus y, that is just an expression. If I say 2x plus y equals 5, then that is now an equation. Okay, we're going to get into algebraic equations after this section over here. So let's first introduce, let's introduce polynomial to us, okay? So a polynomial is an expression made up of sum of different terms. So I'm looking at page 74 and I'm looking at this keyword over here. So what I want you to do in your book, I want you to put this into a nice little box, write a heading term 2, topic 8, algebraic expressions, and write out the keyword polynomial, an expression made up of sum of different terms. All right, let me explain what the term polynomial means. Poly comes from a Greek word many, and nomial comes from the word terms. Okay, so really polynomial means many terms. Okay. Now, there's a few blue boxes in your textbook that I want to go through, so I'm going to read them and you guys can follow. So the first box says, when there's no sign in front of a term, you can assume that the term is positive. A negative term will always have a minus sign in front of it. The sign is part of the value of the coefficient. Okay, we already know that. So if I write number 2, we know it's positive. If I write minus 2, we know that number is negative. Okay, remember variables are letters that can take on different placeholders. So x, y, a, b, c, those are all variables that we can assign values to. We also have constants, which are just numbers, 5, 6, 7. We cannot assign a number 5 any other value apart from it being number 5. Then we have coefficients in front of the variable. So if I write something like this, minus 2x, okay, x is the variable, minus 2 is the coefficient in front of the variable. Remember, the sign in front of the coefficient belongs to the coefficient. So if I ask you, what is the coefficient of variable x? It's not 2, it is negative 2. Okay, and obviously we can have many other variables. We can have y and z like that. Okay, now does it matter in what order I write these variables? No. So x, y, z equals to z, y, x. Okay, so that's basically an example of this would be saying 2 times 3 is the same thing as saying 3 times 2. So if we change our numbers or variables around when we multiply, the answer does not change. Okay. Now the convention in maths is to write variables in alphabetical order. So if I have something like this, z, y, x, I want to rewrite it as x, y, z. Okay, it's not incorrect to leave it like that, but we like to write it in alphabetical order. All right, let's move on. You can add or subtract like terms, but you cannot add or subtract unlike terms. Okay, you've heard this before. Apples to apples, bananas to bananas. If we are adding variables together, we need to add like variables together. We cannot add x's and y's together. So if I have an expression that says 2x plus y squared, all of these terms are different, okay, and all the variables are also different. Here's a x to the power of 1, y to the power of 1, and y to the power of 2. We cannot add anything there together. But if I had another term, let's say plus x and plus 2y squared, then we could add like terms together. What are the like terms here? It is the 2x over there and the x, and we have the y squared over there, and we have a y squared over there. So we can say that equals 2x plus x is 3x. Okay, remember, x is anything. It's counting apples or chairs or bananas or cars. It doesn't matter what x is. But we have 2x's here, another x over there, so that gives us 3x altogether. Now, do we have any other y's? No. So we leave that y alone, plus y, then we have y squared plus 2y squared. Again, 1y plus 2y, 1y squared plus 2y squared equals 2 plus 3y squared. All right, so again, we are adding like terms together. That is called simplifying, and we're going to be required to do that. Okay, now let's talk about different types of polynomials. So poly, remember, means many, okay? But we can have a polynomial with only one term. That is going to be known as monomial. So mono means one. If we have two terms in the expression, that is going to be a binomial. Bi means two. If we have three expressions or three terms in an expression, it's going to be called a trinomial for three terms. If we go anything above 3, we're just going to call it a polynomial. Okay, so if we look at the final answer over here, we can see that this is a trinomial. Okay, there's three terms over here. All right, so let's carry on. So we've done basically page 74 and 75. What we're going to do is we're going to start with exercise 8.1. I'm going to work through it with you, so I'll do parts A and B, and you guys are going to do the rest of each one of those. So you'll have something to go on, and you can also practice yourselves. Okay, so that will be exercise 8.1, which we'll do just now. And then on the next page, page 76, I'm going to do the worked example with you, which already has all the answers. I'll talk through it, explain how they get the answers. And then exercise 8.2 is going to be for homework for you guys to try. Remember, if you get stuck, look at the worked example above, or go through the textbook yourself slowly. It's not that hard. Or you can watch this video again and see how you go. But guys, I want everyone to try this. I don't want you to tell me that, no, I didn't understand. I want you to try this. We've done this in class. We've done this last year. All right, so let's continue. Let's start with exercise 8.1. Okay, you guys can write 8.1 in your books. I'll write it on the board. Right, exercise 8.1, number 1. Okay, so exercise 8.1, number 1 says, which of these expressions are polynomials? If the expression is a polynomial, describe the polynomial by the number of terms it has. Okay, so let's look at A. Okay, is A a polynomial? Yes. Okay, it has two terms. So it is a binomial. Okay, so what do they want? Which of these expressions are polynomials? If the expression is a polynomial, describe the polynomial by the number of terms it has. Okay, so for A, 1A, we have minus 13x squared y plus 52y. Okay, so let's describe it. Well, we see two terms, therefore this polynomial is called a binomial. Okay, so we'll write here binomial. Okay, binomial. Right, let's continue. If we look at B, what do we have at B? 1B, we got 2a squared minus 3b squared plus 16. Okay, so we have 1, 2, 3 terms. What is this known as? A trinomial. Okay, trinomial. All right, so then C and D you guys can do so that you can do it at home. Not B, number 2. write down whether these polynomials are monomials, binomials, or trinomials. Okay, so they've given this to us. We need to again figure out what is going on. So let's do 2a. 2a, what do we have? We have minus 4xyz. Minus 4xyz. Okay, what is this? Well, it has one term. It is a monomial. Okay, easy. If we look at b, how many terms do we have there? So for b, we have 17a squared bc plus bcd minus 112ac. All right, first we have to look at this and see, do we have any like terms that we can add? Well, no. This has got a squared. There's no a or a squared here, and there's no b over here. So there's no terms that we can add together. Therefore, let's count the terms. 1, 2, 3. This is going to be now a trinomial. Okay. Now, guys, if I give you something like this, if I say x plus x, is that a monomial or a binomial? Okay? And the answer is this is a monomial because x plus x is simply 2x. Okay? And 2x is one term, which is a monomial. Okay, so if there are like terms, we have to add them first, and then we're going to comment whether this is a binomial, trinomial, etc. Okay, so this was just an aside. All right, so 2a and b we've done. You guys can do c, d, e, and f. All right, number 3, it says simplify if possible. Okay, so simplify means add like terms. Make things smaller or shorter than what I've given you. All right, so let's look at 3a. 3a, 26a plus 4a minus 8a. Okay, are these like terms? The answer is yes. We are counting the same thing. We are counting a's. Here we have 26a's plus 4a minus 8a. So we are adding the same things together, so we can add them. Let's go ahead and do that. 26 plus 4 is 30. 30 minus 8 is going to be 22a. Okay, so this one did simplify, and our answer is 22a. Right, let's look at 3b. 3b, we have 17x minus 12x plus 33x. Okay. Again, are we adding like terms? The answer is yes. We are counting x's. X, x, and x. So let's add them all together. 17 minus 12 gives us 5x. 5 plus 33 gives us 38x equals 38x. Right. Guys, this exercise is very straightforward. It's just introducing you to, or rather recapping your knowledge of algebra that we've done last year, and we've started in term 1. So here we're just looking at coefficients, what are terms, what are variables, what are polynomials, and how can we classify different polynomials. Okay. Alright, great. So that was number 3. You guys can do the rest of them. So if you look at 3D, this is where the order of variables doesn't matter. So we have ABC, BCA, and ACB. Remember what I said before? It doesn't matter in what order we multiply, the answer is still going to be the same. So 1 times 2 times 3 is the same as 3 times 2 times 1. And the same as 2 times 1 times 3. Okay. So you guys can figure that out. Let's continue to number 4. So it says again, simplify if possible. Okay, so I'm going to take this off. Right, 4a, simplify if possible. Okay, so we have 2a minus 3b plus 4a minus 5b. Okay, so here we have two different variables. We have a and b. Again, we're going to add apples to apples and bananas to bananas. Okay, so here we got 2a, we got another 4a there, we can add those, and we have this negative 3b and negative 5b that we can add together. So let's go ahead and do that. 2a plus 4a gives us 6a, minus 3b minus 5a gives us a minus 8b. Guys, also remember, with the multiplication of signs, remember when we are multiplying signs. Here, we are not multiplying anything. We are just adding things together. So I know a lot of you get confused with that. So keep in mind, here we're adding, there's no multiplication anywhere. Okay, so when I say minus 3b and minus 5b, I'm not multiplying those signs. I'm simply adding like terms together, and that gives us a negative 8b. Alright, so that was 4a. We could simplify. Let's look at 4b. Okay, 4b we have 6xy plus 2xy minus xy. Alright, are we counting like terms? Yes, we are counting xy's, xy's, xy's. 6 plus 2 minus 1. Remember, if there's no number in front of the variable, it is always 1. I can say an apple or 1 apple. It's the same thing. Okay, so let's add these things together. 6xy plus 2y, 2xy is 8xy, minus 1xy will give us 7xy. Okay guys, when you're writing these variables down, they are cursive variables. Okay, and they are small cursive variables because there's a distinction between small and big letters in maths and cursive and non-cursive. Okay, so here these are all cursive X and Y's, A's and B's, etc. And they are not big letters. Guys, I don't want to see an X looking like that. Okay, that looks like a multiplication sign. Okay, so don't do this, please. Okay. Right, so that is exercise 8.1, pretty straightforward. It shouldn't take you more than 10 minutes to answer this, so please do that for homework. Now let's continue. So, the degree of an algebraic expression is one variable is the highest, the degree of an algebraic expression in one variable is the highest power of that variable in the expression. When you simplify an expression, you usually write the terms in ascending or descending orders of powers. Okay, what we are talking about is if I have an expression such as, okay, let me give you an example. So let's say we have an expression 4x squared plus 3x plus 5. Okay, this is written in descending or powers of x. Okay, so it's x to the 2, x to the 1, and here we have x to the 0, which is always 1. So that's why we have a constant. Okay, so the convention is write them in descending order. And then the degree of a polynomial is the highest power that we have of a particular variable. So the degree here would be 2, because 2 is the highest power of a variable that we have. All right, let's look at the worked example. So that is on page 76 in the yellow block. It says, given the expression, okay, let me write it down. So with this one, you guys can just work with me on the example. You have it in your textbook, so you don't need to write this down again. So we have 8x to the 4 plus 4x minus 3x squared minus 12 plus x cubed. Alright, so that is the expression that they've given to us. It says A. Write the expression in descending powers of x. Okay, descending means we are going down. So we're starting with the highest and we're going down. The highest power that we have here, we exponent, is 4, then 3, then 2, then 1. Okay, so let's rewrite this in descending order, or rather let me do A. Okay, so descending order. So we have have 8x to the 4. The next one is x cubed, so it's plus x cubed. Then we have x squared minus 3x squared. Then we have x, so plus 4x. And then we have final minus 12. Okay. Remember, the constant always comes last. So we start with the highest exponent and we go in order, constant comes last. So here we've rewritten the expression in descending order of x. Alright, B, how many terms does this expression have? Okay, firstly, let's look at it. Can we add any terms together? The answer is no, because they all have different powers of x. Okay, so we cannot add them together. So how many terms does this expression have? Well, 1, 2, 3, 4, 5. Guys, remember, terms are separated by plus and minus. Bless me. Don't worry, it's not corona. It's just very cold here. Okay, so B. How many terms? We have 5 terms. Right, C. What is the value of the constant term? Remember, the constant term doesn't have any x's next to it, so the value of the constant term is negative 12, not 12. Remember the negative sign with each coefficient. Okay, let's look at D. Okay, write down the coefficient of the x cubed term. Coefficient of the x cubed term, there's our x cubed. What is the coefficient here? Remember, if there's no number, it is 1. And it is a positive 1. So the coefficient here is 1. Okay. E. What is the exponent of the first term? What is the exponent of the first term? Remember, this is known as a power. This number is known as an exponent. So they are asking, what is the exponent of the first term? The first term is here. Well, whichever first term, it's the same first term. The exponent is 4. Okay. Then the last one, F. What is the value of the expression when x equals to minus 1? Okay, so when x equals to minus 1, okay, I'm going to rub this out. Okay, F. Now guys, remember from last term when I said when we substitute values into an expression or an equation, we use brackets. So I want to see that substitution happening. I don't want you to do this somewhere on a piece of paper, work it out and give me an answer. Okay, I want to see the steps, I want to see the brackets, I want to see how you're substituting that value in. Okay, right, so let's do it. We are putting in a value of minus 1 for x. Okay, so it will be 8. Now, whenever you see the x, put brackets around it and put the value in. So here we have minus 1 to the power of 4 plus 4, open bracket, minus 1, close bracket. Minus 3, open bracket, minus 1 squared, minus 12 plus minus 1 cubed. Okay. We could have substituted into the other equation where it was already in order, but it doesn't really matter. So we're going to get the same answer. So minus 1 to the power of 4, remember, if we are taking a minus to the power of an even number, the answer will be positive. If it's an odd number, it will be a negative. Okay, so negative to the power of 4 is going to give us a positive. 1 to the power of 4 is 1 times 1 times 1 times 1, which is just 1. So this thing over here is just going to be a positive 1. So it's 8 times 1, which is just 8. Okay. Here we have positive 4 times negative 1. Here we are multiplying signs. Positive times a negative gives us a negative. 4 times 1 is 4. Next one, do the brackets first. So we have minus 1 squared. Minus 1 times minus 1 gives us a positive 1. Minus 3 times positive 1 is going to be minus 3. Then we have minus 12. There's nothing to substitute into here because there's no x, it's just a number. And then the last one is minus 1 to the power of 3. Well, remember what we said, it's an odd number, odd powered. A negative to an odd power will give us a negative answer. 1 times 1 times 1 is 1, so this is going to be negative 1. Okay, and the answer that we get, 8 minus 4 is 4. 4 minus 3 is 1. 1 minus 12 is minus 11. And minus 1 is minus 12. Okay, so the answer we get is negative 12. Alright, so this is a great example to show you how we substitute values for variables. So we could have the formula and then we put in a particular value. We could have substituted a value of 1 or 2 or 5 or 1,000 into this expression to see what we are getting. Alright, cool guys, so this was our first lesson. We are on 26 minutes already, so I think we've done enough. So what I want you to do is do exercise 8.2 for homework. So let me write that down for you. So we have exercise 8.1 complete. Okay, and we have exercise 8.2. Also you need to, or complete questions. And then 8.2 you just need to complete. Okay, and this is homework. And today's date is the 6th, so 06, 05, 20. Alright guys, so that is your homework. That's what we're going to go over when I see you during your Skype session. So, I mean, I'm not going to go over every question. I mean, I can give you the answers for that, no problem, but I want you to go through it and tell me what went wrong or if you had any difficulties. Guys, remember there are answers in the back of the book. So the answers are there for you to check if you got it right. It's not for you to just write down the right answer and pretend you did it yourselves. I want to see the workings, please. Alright, cool guys. I'll see you in the next video lecture, which is going to be tomorrow. And we are going to carry on with this. We're going to do combined operations in algebraic expressions. So we'll do that worked example, and we'll go on to exercise 8.3 and 8.4. Okay guys, I hope you enjoyed this lesson, and I'll see you tomorrow. Ciao.